Hi, welcome to your second video on domain and range. Let's finish up where we left off. First of all, we left off with the idea of looking at this graph here. We said there's two ways to interpret it. This looks like maybe it's going kind of straight down, or maybe it's going diagonally forever in the positive direction on the x-axis. If you look at it as going forever and not hitting kind of a wall here, then this would be our range and our domain. However, there's this idea of something called asymptotes, which often exist on graphs, and it's like an invisible wall that the curve or graph approaches but never reaches. So in this case, maybe you're looking at this one and thinking, hey, there's an asymptote. Maybe this is approaching this invisible wall here. In that case, our domain would be that. Oh, let's go back. Our domain would be this. All right, now we see it goes from -5 to 5, but never reaches 5. We can see no equal sign. Important concept. That's why I want to begin this second video with that, just to make sure we take one more look at that. Now, there was a TOK question for you as well. It says that around the world you will often encounter different words for the same object, like trapezium and trapezoid. All right, maybe you've heard both those words or just one, but they are just one word. One is used in the UK and one is used in the US. Or other words like that are root and surd, basically have the same meaning, like square roots and surds. Sometimes more than one type of symbol might have the same meaning, such as interval and set notation. We looked at that in the last lesson. They mean the same thing, but just different symbols. So to what extent does the language we use shape the way we think? How about you answer that? Okay, let's do some more practice problems here. In these four here, we're trying to get a domain and range for each of these graphed functions. So begin with, let's try A first. Or I'm not sure if it's going to show all the answers. How about you try for A and C? I mean, try all of them, but I'm going to have you put in your responses for A and C. And here is all the answers for those. So check carefully. I think most of those are pretty straightforward based on what we've talked about. Yeah, just take a close look. Okay, here's a word problem with domain and range. So it says the path of a golf ball after being hit by a club can be modeled by this function, where t is time in seconds and h is height of the ball. So use your GDC or calculator to sketch a graph of the ball's path. So put in that function as your y1 function using x instead of t. Graph it, make sure you set your window to capture the whole graph. You'll see the shape. And then it says explain why this is a function, and then find the t-intercepts, in other words the x-intercepts. Where does the graph hit the y-axis? Find those points. Find the maximum value. You can find all those by doing second and calc. I think there's something there where you can do max, and there's also you can do I think you can do roots. I can't remember what the exact wording of it is. Let me check. I found it here, so I press second and calc. That's where we usually go to find the intersect of two graphs, but in that menu you'll see 0 is number 2, and that's to find the x-intercepts. So that's when it's talking about t-intercepts, you'll do that. And there's minimum and maximum there as well. So you can use those functions on your calculator to find these values for you. After you found that, you can then write a domain and range for this situation. Okay, so let's check. So here's the graph you should have seen on your calculator. You found out that these intercepts, the x-intercepts or t-intercepts as they're calling them here, are 0 and 3.73. So now you know your, let's see, domain. Yeah, the domain is from 0 to 3.73 because we're not considering negative y values, right? So because the ball cannot be at a negative height. So we're only looking at this function here. We're not even though the function goes forever here when you graph it in both directions, we're ignoring that because we're only looking at this part here. Who just joined us here? Hello, everybody. You know that voice, everybody. That's Philip. And now you can see the range then, since we've cut the graph off here and here, the range is from 0 up to the maximum point of 55.9. So again, this is important that you've tried all these things on your calculator actually, so you understand how to get the max, the intercepts, and then how to get that domain and range from the values you found. So study that one carefully. Okay, next question looks like this. Now we have what's called a piecewise function. That means a function that is in parts, right? Part of the function is this, 2x, which is a line. Part of the function is y equals 4, which is a horizontal line. And part of the function is y equals, I mean, we see f of x, but I'm just saying y equals half x plus 2, another line. So basically, this overall function is broken up into 3 lines, and there are 3 different lines. This line exists only between x values of 0 and 2. This line exists between x values of 2 and 4. And this one exists between x values of 4 and 8. So if you were to graph that, I think we're going to see the graph in a minute. You'll see what it looks like. But for now, we're going to find f of 2. So you look at this and you're like, okay, the input is 2. So if I put an input of 2 here, well, you got to look at when are x values equal to 2. Okay, so x values are 2 right here, because this part of the function exists between x values of 0 and 2, including 2, we can see equal to 2. So that means when you're looking for f of 2, you're going to use this portion. So 2 times 2, and the answer to that is 4. How about f of 3? Well, f of 3, let's check the answers here. F of 3 would be 4, because now x equals 3 exists in this set of values here, right? It exists between 2 and 4, so we use this function, but there's no x here, so no matter what you put into this function f of x equals 4, you're always going to get an output of 4. It's a horizontal line. And finally, looking for f of 7, that means we're looking for x values between 4 and 8, because 7 lies in between there. That means we're going to use this portion of the function for f of 7. We put a 7 in there, and we get that answer there. So now the sketch of the graph looks like this. It's important you know how to do this by hand, okay? So you should be able to sketch this by hand. Maybe you can practice. But basically, between 0 and 2 on the x-axis, right? So between 0 and 2, the function looks like this, 2x. 2x means a line with a slope of 2 and a y-intercept of 0, because there's nothing past the 2x, right? So it's like plus 0. So we have a y-intercept of 0 and a slope of 2. So we go up 2 over 1. Up 2 over 1. So there's that line we're drawing, but that line only exists from 0 to 2, so it only exists from 0 to 2 on the x-axis, and then it's done. And now the next function kicks in, and that exists between 2 and 4. So between 2 and 4, the function looks like this. It looks like y equals 4, and that's what we see here, a horizontal line, y equals 4. Finally, we have the third part between 4 and 8, so now we're going from 4 and 8. Our domain is 4 to 8. Between those x values, it looks like this. And this is a line with a slope of 1/2 and a y-intercept of 2. So if you follow the slope here, it goes up 1 over 2, up 1 over 2. That's the slope. And the y-intercept of 2, that means if you trace this back all the way to here, it would intersect at 2, y-intercept of 2. So that's really important, again, that you know how to graph that. Okay, find a domain and range of this function. Check your work here. How about this one? Find the domain and range of each of these. This one's a little different. We have this solid point, this open point. You should know that when you see a solid point, that point is included, and when you see an open point, it is not included. So let's take a look. Okay, so the domain here is x values from -2 all the way to 3. Wait, is that right? Yeah, -2 to -1, and then there's like a break, and then it begins at 0 and goes to 3, right? The x values again begin at 0 to 3. And you can see it says -2 up to -1, not including -1 because there's a hole there, but including -2 because it's shaded here. And likewise, when we begin the graph again here at x equals 0, it doesn't include 0. We can see there's not the equals there. It doesn't include it, but then it goes all the way to here to x equals 3, and it does include that one, so x equals 3 is included. All right, those are all important details. You can see it in set notation and in interval notation. The range is given like this, from -4 all the way up to 1, -4 all the way up to 1. And notice that since this one ends at y equals 0, and this one begins at y equals 0, but this one's shaded, y equals 0 is included, so you don't have to put a break there. It just goes straight through from this value all the way to this value. All right, try the next one here, B. Check your work here. And then we have these ones. I think this might be getting near the end here. This one, check your work, domain, and range written in all the forms. Again, there's a hole here, so when you see from -3, it does not include it, but then it goes this way and then goes forever to infinity on the x-axis, and then on the y-axis it starts at -4 and goes forever, because even though it ends here, this arrow goes forever, so it goes from -4 all the way up forever, -4 to infinity. Next one looks like this. Domain and range looks like this. This one goes forever this way, so it ends up covering all the x values and all the y values. And last one here, let's assume there's an, let's make that a solid circle, shade that on yours. And let's assume there's an asymptote here. This clearly is going up, 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 so maybe there's that invisible wall, and that asymptote is a vertical asymptote at x equals 1. So now the domain is this, and the range is this. Check your work carefully. There's a lot of fine details here that you should understand, and we'll see you next time to continue our discussion of functions. If you feel like you do need a little more practice with that, there's a bonus practice linked on our lesson calendar. It includes lots of practice with functions. Maybe doing a few more would be a good idea to make sure you got this skill down.